It's nice to be here to speak to you all today. It's my first trip ever to the United States. It's nice to be in the company of friends. It's nice to meet you all and be able to put faces to names after so many years of corresponding with you all via the various email lists and various websites. It's been a pleasure to meet Tim, finally meet my good friend Bob Carmody, who we've been corresponding together for 2 or 3 years now. It's been nice to meet Chelsea. So I've had a great time. I think today's been a very successful day for Chicago TI-99ers. I'd like to thank Hal. I think Hal's done a great job here today. I'm just going to get this so I know where I am with it and what it's doing. Oh, here we go. So, TurboForth. This started as a bit of fun, as they always do. 3 years ago, I decided I was going to build myself a little computer on a Vera board with a few buttons and an LCD, buzzer, and some LEDs. I was going to use a TI-99 because it's one of my favorite processors. Bit of ROM, bit of RAM, job done. So I got all the parts, spent the money, bought all the parts, and thought, okay, what am I going to run on it? I'll need some kind of operating system. Maybe Forth. So I had a look around and I decided, yeah, Forth. There was only one problem. I knew nothing about Forth at all. So I had to write my own Forth system. 3 years later, all the components that I bought are still in a plastic bag under the bed where they were placed 3 years ago. But we do have a working Forth system, but it's TI-99 4A. It's called TurboForth because most of it is written in assembly language to be as fast as possible, and it's fairly highly optimized assembly language for the bits that need to be optimized. It's not a disk-based system. It's a cartridge. It's a 16K cartridge, and every single byte is used. There is 0 free bytes in the cartridge. So you can imagine the amount of hacks and refactoring I had to do to squeeze stuff in there. As I say, it's very fast, and it's a fully featured Forth 83 compatible Forth system. So you should be able to take code that's been run elsewhere, written elsewhere by other people, and just run it. Normally, when the system starts up, on most systems you'll just get a display like that. But on mine, I've got mine customized for my own requirements. So I programmed mine to come up with a menu. But I guess what I should do is start with talking about what Forth is. Most of you will have heard of Forth over the years. It's by no means a new language. Forth went into mainstream use in 1970. It was designed and invented by a guy called Chuck Moore, and he first put it to use at the national, I think it was NRA, National Radio Observatory, or NRO, and it was used to control radio telescopes. It was running on a PDP-11 with 8K of RAM, a tape drive, and a drum, I think, hard disk or something like that. And it was one of the first. At that time, people were using paper tape and punch cards and writing a program on a mainframe like a PDP-11 consisted of punching your cards, putting them into a card reader, load the cards, and see what didn't work, and start again. And he came up with this. He just thought, that's crazy. And Forth was born, where you just type your code in real time, and in those days that was unheard of. And Forth is still with us today. As a programming language, it's completely, I would say, unique. There is nothing like it. And if you are used to writing software in any other language, be it assembly language, C, C++, Fortran, .NET, whatever it is, unfortunately, none of that experience will mean a damn thing, because this is completely different. You have to take all of that knowledge that you've built up over the years and you have to put it to one side, because this is completely different. But it is very simple, and that's what people have a hard time understanding, just how simple it is. What is Forth? Forth is words and numbers. That's it. Congratulations, just learned Forth. That's all there is to it. That's perfectly valid code in Forth. There you go, just written a Forth program. What it's actually done is it's put the number 2 on its stack. If I want to put another number on the stack, there you go. Now I have 2 values on the stack. I can have a look what's on the stack by doing .s. It shows that 9 is on the top, 2 is underneath it. There are no such things as operators in Forth. In say BASIC, we have the notion of operators. Things like plus is an operator. Multiply is an operator. We have plus and multiply and things like that in Forth, but they're not operators. They're not part of the syntax of the language. They're just words. As I said, Forth is numbers and words. So if I want to add those 2 numbers on the stack, I just say that. And now I have 1 value on the stack. What happened is, plus here is a program. It's a word that does something. What it does is it takes 2 numbers off the stack, adds them, and replaces them with the answer. So I do .s to show you what's on the stack. I have 11. That's Forth. Let's get rid of that so my stack is empty. You can make your own words to do things in Forth, and you build those words using previously defined words. So each word stands on the shoulders of other words. When TurboForth starts up, I think it has 261 words that it knows. Yeah, 261. And you can add your own words. So I can make a word called, Fred. It says hello. Now the system knows of a word called Fred. How do I execute the word Fred? Well, I just type his name and it says hello. It's as simple as that. Now I can create another word which references Fred. So now when I run Bill, he runs Fred. Words stand on the shoulders of other words. You can put numbers inside definitions. As I said, Forth is just words and numbers. There is no syntax. There is no concept of having to do an open parenthesis, put something in, remember to put a closed parenthesis. You'll be familiar with things like HR in BASIC, where you have to type HR, you have to have an open bracket, you have to separate the numbers by commas, and you have to have a closed bracket. If you think about what those things are, the parentheses and the commas, they're not there for you, the programmer. They're there for the computer. The computer needs the commas to separate the numbers so it can understand what it is you're telling it. Because you have a stack in Forth, you don't need any of that. Numbers go on the stack, always. So if I want to... That is a perfectly valid Forth program. Excuse me, I'll just get rid of that. That's a program. What this does, colon switches on the compiler and says, hey, we're going to build a word that's the name of the word that we built. It starts compiling as soon as it's created this word. The compiler is switched on, and then it compiles whatever it sees until it gets to here, which is the signal to switch off the compiler. So what will happen when we run this word? Well, it'll just put... I'm typing on the console. It just puts 3 values on the stack, which is exactly what we asked it to do. I'll just reset this and clear it out and show you something a bit more sophisticated. It's quite a fully featured language. It has, it's fully structured. You have do loops, for next loops, while loops, if then. You don't have go-tos because you don't need them. Routines can be nested, and they will unwind automatically, just like calling subs in Extended Basic. You can just nest and nest and nest. Just to give you an idea, here's a quick loop. That's a little program. At runtime, when I run this by typing test, it will put 1000 and 0 on the loop. Then it will execute the word do. Do knows what to do. It takes 2 values off the stack and uses them to run a loop 1000 times. I is a word. It's not like a variable in BASIC where you'll say for I equals. I is a word which always returns the current index of the loop. Dot displays the top value on the stack. So what I does is places the current index on the stack, and then the dot will display it. Then we loop back to do again.
Well, you can use your mouse to
Oh yeah, good idea. So when we run it, we get that. And when I said,
can you do the same loop as I did with the square roots? With square roots?
Doesn't do floating point natively. I have to load stuff in. But what I wanted to do was quickly show you a similar thing with Extended Basic. So in Extended Basic, we would say something for I equals 0 to 999. Print I. Next I. So let that run. Reset this. So it's pretty fast. We did some tests. It depends on what you're doing. It can be anywhere between 50 and 70 times faster than Extended Basic. It's generally around 50 times faster. Things like this will be a little bit less because the bottleneck isn't doing any calculations. It's scrolling the screen. That's the actual bottleneck. Yeah, Extended Basic's not even finished yet. Source code is stored in blocks. You can create a file on disk, and that file is divided into things called blocks, and your source code lives on those blocks. There's a built-in editor to edit your source code, so you don't need to load anything. It's all in the cartridge. So what we're looking at here is source code. Each one of these is a program. This is the code here for Mark Hull's TI-99 to support that. TI sound chip, Roman numeral program, sorting, and from block 9 on we've got the assembler. Some of you may have seen some of the stuff here. You've got we already have an assembler, so you can write machine code using this. But you don't need to use editor assembler. It has a built-in assembler. Well, it's not built in, you load it, but that's available. You have 32-bit library for dealing with large numbers up to 4.2 billion or whatever they are. You have floating point, and then we've got various libraries for doing various file utilities, copying blocks, printing blocks, etc., etc. I guess I should show you how to. So find an empty block, 50 maybe. No. 51. So you can put code or script in a block. So if I do that and do 51 load, it executes what's in the block. If I type flush, it's now written that block back to disk. So if I reset the machine, there's the code that I wrote, just persisted back to disk. You can have as many block files as you've got room for on your hard disk or whatever. It's completely compatible with CF7, normal TI disk drives, hard disks, just SCSI disks. In fact, there's nothing we've tried it on yet that doesn't work on. We tried it on the Geneve just now. It runs on the Geneve. It's much faster, of course, on the Geneve. So yeah, it's a full-blown Forth, but it doesn't stop there. We've got to try and support this and generate a bit of interest. There is a website set up just to try and support this, and it's got it's not quite finished yet, but it's getting there. Things like a language reference. So if you want to know how all these words work, it'll tell you. This is a description for the word dupe, which duplicates a value on the stack. You've got a range of words to manipulate the stack. So if I put 100 on the stack, and then if I type dupe, it duplicates what's on the stack. If I put another number on the stack, there you go, and I type swap, it swaps the two numbers on the stack. If I press plus, it adds them. If I do plus again, it adds them, etc., etc. So it's a bit of a whirlwind tour of Forth. For those of you that don't know how to program in Forth, it's not a difficult language to learn. It's just the concepts are a bit strange because it's a stack-based language. There's a book in development. It's not finished yet, but it's getting closer. So it's a real book. Which you'll be able to buy from Amazon, anywhere. That'll be available within a couple of months. Things like the assembler, they all have documentation in PDF form, proper written manuals that tell you how to use it. So it's not just a case of there's a language and you're on your own. There is support. There's also a mailing list, a Yahoo mailing list if you want, if you need help. There's about 40, 50 people on there, all Forth programmers, so they should be able to answer your questions if I can't. So yeah, it's just a quick whirlwind tour. Any questions? Silence.
Could you show us some demos? There were some demos on the second one.
Say again?
Can you show us some demos?
Yeah, I can show you some stuff. Show you something I was working on. Now then, I'm in a different screen resolution and all the folders have moved. No, I can't see it anywhere. There's my source code folder. This way. This is some bit of something I did just for fun. I wanted to see how quick this could run. Take that out otherwise. This is being compiled as it's yeah, and it's being compiled as it scrolls up. It's compiled. It's ready. I just keep it running. There's a kind of snake thing. I just wanted to see how quick it would run. That's all written in Forth. There's no tricks. There's no assembly language or anything going on there. That's just using the stuff in the built-in vocabulary.
Pretty impressive.
You can just, at the moment anyway, I'll make it into a full game when I have a chance, but I wanted to see if it was worth making it into a full game, if I was going to have enough horsepower. And it's looking okay. Each time you run it, you get a different, so you should get a random maze.
Do you have access to the bitmap screen?
You don't at the moment, but I'm going to produce a loadable extension, like a module, which you'll get lines and boxes and stuff, fills and stuff. Yeah. Supports all the 32 sprites, etc., etc. It supports 80 column mode if you have an 80 column card. If you do run it in 80 columns, then the editor reconfigures itself to run in 80 columns. It knows if you're in 80 columns. I think that gives you an idea of the speed that we've got going on there, because there's quite a lot going on. There's quite a lot going on there. Each of the snake bodies is a separate, from a logical point of view, is a separate object. So they're each looking to see if they're about to bump into something. Doing it that way is simpler because you have one piece of logic which you apply to each cell of the snake. Plus we're doing repeated redefinitions of characters in VDP to do this, to move the brick wall up, and then to move the background up at a different speed from the brick wall. That's running at half the speed of the brick wall. Plus we're reading the screen to see if we're about to collide with an object. Having to erase each cell of the snake and redraw it. And you'll see that the snake changes direction when the character changes direction, so it's facing in the right direction. There's quite a lot going on there, but it doesn't take up, I don't think it takes up very much space. Let's have a look. If I do that and then paste the code in. Yeah, it takes up 1.3K. But you'll notice that it's highly structured. It's highly structured code. You know, we're using if blocks, and we're using begin until loops. So this code here runs in a loop until the call to joist returns a 1, which is the code for fire. So when I press fire, the loop will exit and the program will end. That's just how I've got it configured at the moment. The actual logic to do the movement of the snake is all in there. That's it. The rest is moving. This part here is moving the background. This is moving the wall. This just draws the obstacles on the screen, sets up an array with the positions of the snakes, sets up the colors. This does the definition of the graphics, and we've got some constants up here. You've got constants, you have variables, you have values. I guess I can show you those.
What I could see is it's a very structured, but it is not necessarily, quote, object-oriented. You had mentioned objects, which is why I bring up the term, and only the reason I bring up the term.
Okay.
It's
It's not object-oriented.
okay.
Forth came out kind of before that
Yeah.
kicked off. But there is the concept of inheritance does exist in the language, and does exist in this version of Forth. For example, I have there's a word called create, and you use that to create dictionary entries. So a word now exists called Fred, but there's no code. So that looks a little bit strange. So it would be very strange, for example, if I was able to execute Fred, but I am. It runs quite happily, even though there's no code there. So clearly there must be code there, otherwise you couldn't have executed it. The answer is it's inherited code that its parent, create, laid down for it. So I can then modify, but point is, I can modify the behavior of that word later on. I can have a number of words in memory. I can have word A, word B, word C, and then I can create a word called Fred, and I can point it at A, B, or C, and change it at will, which is a very efficient way of doing things without doing, for example, sequential checks. If this, else this, else this. You don't have to do that. You can just rewire a word and make it do something else whenever it's executed. But I'll show you quickly. I'll show you constants first. Rather than they're like variables, I guess. But a constant like that creates a word called 10, and rather unsurprisingly, whenever you execute the word 10, it puts the value 10 on the stack. That's a constant, and it can't be changed once it's created. You also have values which can be changed. So I'll use my favorite word, which is Fred. Now whenever I execute Fred, dot just means display what's ever on the stack. So Fred executes, he puts his value 100 on the stack, dot executes, which takes the 100 off the stack and displays it. So that's all that's going on there. But I can change the value of Fred because it's a value. So I can say 150 to Fred. Now Fred has the value of 150. I can also do math with it. So I can say minus 20 plus to Fred. Now Fred is 130. Those are values, and they are syntax friendly. They look nice in source code. And you also have variables. By the way, constants and values were not in the original versions of Forth, but this is an enhancement that's been added, which I've just simply copied. You also have variables, and variables have a different syntax. So now we have a variable called John, and they work slightly different to variables in BASIC, where you would say something like John equals 100. Variables return a pointer always. So when you execute John, which is a strange concept in itself, if you're familiar with any kind of programming language, how can you execute a variable? Well, we just did. And that's because it's a very simple kind of object and has one method, and that method is to return a pointer. And it's an address, and it's the value of John is A312. So it's pointing at a memory location, A312. And we can write data into that variable. So I could say 100 John store. The word exclamation is just a word which means store. So 100 goes on the stack. John executes, which puts an address on the stack, and then store executes, which takes a value, an address, and puts the value in that address. There's another word called fetch, which is the @ sign. He requires an address on the stack, which is what John supplies. Well, that wasn't supposed to happen. Oh, I printed it in hex, that's why it's 64, so sorry. John fetch dot, yeah, so we get 100, but that's, so we're using a level of indirection. That's how variables work. But values are sort of more syntax friendly, I guess. I wonder if there's any other demos I could show.
You know, not exactly practical, but say I was someone wanting to program, say, a game of old sailing warships against each other. Somebody might have some idea of doing something like that. What sort of advice would it be, particularly good, particularly bad, to try and put that into this language versus, say, maybe using something else like, I don't know, Extended Basic?
Well, it's much faster than Extended Basic. And this also introduces some paradigms which simply do not exist in Extended Basic. They're not particularly special to TurboForth, as I've written it. They're Forth paradigms, but they're paradigms, nevertheless, that you can leverage to your advantage. I guess I should explain the block system in a little more detail.
Mark, do you understand why I picked that particular example?
Oh, yeah.
Okay.
Explain.
Forth code is distributed in source code format. So if I load the assembler, well, I'll show you the assembler first. This is a full-featured TMS-9900 assembler on steroids, I guess. It has begin until loops. It has if, else, end if in assembly language. You don't need labels. In fact, it doesn't support labels because you don't need them. If you want to say, whereas in assembly language you would normally do a condition and a jump if the condition is false, or simply continue if it's true, you can just say if, run this, else, do this, end if, and the code continues at the assembly language level. It's on steroids. But this is the assembler, and it's 4 or 5 blocks, so it's 5 blocks of code. The point is, it's in source code format. There's no object code. There are ways of saving your code once you've compiled it as object code, but Forth stores its source code in blocks. And when you load them, they're compiled on the fly and your program is available. And you can stack programs in memory. You don't have to have just one program because they're just words that are added to the dictionary. So you can have more than one program in memory at the same time. The thing is, there's no restriction on what you put in a block. It doesn't have to be source code. It can be raw data. And the way blocks work, if I do something like one block, that's actually taken block 1 from disk and put it in memory. It hasn't actually done anything with it, but what it has given us is an address telling us where that block can be found in memory. So it's loaded exactly 1024 bytes into memory. And the reason it's a low address, if you're familiar with the TI's memory map, is because it's not in CPU memory, it's in VDP memory. I didn't see the point in wasting valuable CPU memory space when there's all this VDP space. This system can hold 6 of these blocks in memory at the same time. So it's got a 6K cache. If you request a block, you can't really see it on this because we're running on a PC and it all happens too fast. But if this was on a real TI, if the system was in its cold state now and I typed 1 block, you'd hear the disk drive whir as it called block 1 in from disk. But if I typed it in again, you wouldn't hear anything because it knows it's in the cache. and it simply supplies you the address. It scans its block allocation table and says, oh, it's already in memory. Here's where it is. And you can leverage that. For example, in a game where you may have load and save states, they can be in blocks. You don't need to use like the DV80 files or the F128 files. You can simply use blocks because they're just binary, 1024 binary blocks. And persisting data is no more complicated than finding the start address of the block, adding your offset to wherever you want to put the data and do a write into VDP, and then you would simply execute the word flush somewhere in your program and would write that changed block. It knows that block has been changed and would flush it. Any unchanged blocks don't get flushed because there's no need to. So you have this concept of a block and a cache, which doesn't exist in languages such as Extended Basic. So you could load, for example, preload a load of data at the start of your program, and it's in VDP, ready for when you need it, which you can get at using high-level commands such as block. So it's pretty neat, I suppose.
Okay.
Anything else?
Is there any way to get a value off the stack without actually pulling it off the stack? I noticed the s dot command actually is reading what's on the stack but not actually extracting it.
Yeah.
Because when I see a lot of fourth source code, I notice there's a lot of dupes happening because they're trying to duplicate what's on the stack and then they pull it off.
Yeah. Yeah. The way to examine, if you normally words like if. Let's see if I can do an example here. Well, the only way to, for example, display a value without removing it is to dupe it first. So if I want, 99 dupe dot displays 99 and leaves the original 99 on the stack. And a lot of words consume values off the stack and will replace that value with an answer. So let's make a word that says more than 99. I can simply say 99 greater if whoops. Learn to type. There you go, so I should be able to say, is 56 more than 99? No. Is 100 more than 99? Yes. Glad that worked. So, what happens here is that, I know this looks completely strange. The syntax looks very, very strange if you're used to something like BASIC, because for a start in BASIC, if would come first. But this is a stack-based language, so before you execute a word, the data that it needs to be on the stack. So what happens when this word runs, this is just the name of the word here. What it does is it puts the value 99 on the stack, and then this is a word. It's just a word, just like anything else. And its job is to take two values from the stack and tell us if the first value is more than the second value. What it actually does is it removes them, compares them, and it puts either a true or a false on the stack, a 1 or a 0. If consumes that true or false from the stack, and if it's true, this bit of code here will execute, else this bit of code will execute, then the program will continue and do a carriage return. So when I typed that in, you probably thought that the syntax was completely bananas, but hopefully that kind of made sense. If the value on the stack after this comparison is a true, then we do this, else we do this, then we carry on and we do this. So even though everything's the wrong way round for what we're used to, when you think of it in terms of a stack, it actually starts to make sense. If I wanted to keep a value on the, if I wanted if I wanted to see that condition after the if, then I would need to dupe it. So I would need to say something like, well, in fact, I'll leave the original value that we pass in on the stack on the stack. Okay, so it tells us that the word's been redefined. Now if I say 56 more than 99, it says false, but it's left the 56 on there because we duplicated it. So, quick crash course in Forth programming.
Very nice.
Anything else?
What other than radio telescopes, what real-world applications are Forth used for, and I mean, what kind of popularity does it enjoy today? I mean,
I think it's quite niche these days. It's always been popular in the scientific community and in telemetry and machine control. It's also very popular in the embedded design. It's used often to, while machines are in development, it's used as a simple operating system to test various bits of the hardware out to see if things are working. Every Solaris machine produced has a Forth-based BIOS even today. The BIOS is written in Forth and has a Forth interpreter. You can actually write Forth code with it. If you've heard of the One Laptop Per Child project,
sure.
that has a Forth-based BIOS and a Forth interpreter inside it. You can write Forth on that right now. There's a wiki reader on the market that you can buy. I think it's $99. That has a Forth interpreter built into it. You can hook a serial cable up to it, John was telling me, and type Forth on your laptop and run it on the wiki reader. It stores its code on the SD card. In about 1996, one of the Space Shuttle missions, was it Challenger, launched with over 100 scientific instruments on board, all programmed with Forth. It's very popular in NASA. I don't think so much these days. Other languages have sort of taken over, but very popular. But any resource-constrained system, Forth always outperforms anything else. You can say that the TI is a constrained system. We have just 32K of memory. Yet here we are with a real-time compiler and interpreter. We're not having to, like with assembly code, we're not having to load an editor, write some source code, save the source code, exit the editor, load the assembler, assemble the object file. Oh, there's a mistake. Exit the assembler, load the editor, load the source code. Now, if you've ever done that in any C programming, you'll know that even today, that is your development cycle. If you do Perl or anything like that, that's your development cycle. You edit code in one window, you run a compiler, which may or may not compile, and even if it does compile, who's to say that it's not bugged because it's something you did wrong? In Forth, you test your words as you write them. As we just saw, we typed in this line of code, and by the time I pressed enter, it was ready to be. It was compiled and ready, and that is how that's the development cycle in Forth. You define a word, you try it by supplying data on the stack, so you can run a word in complete isolation from the rest of your program. And when you're happy that that word is correct, you move on and you write the next word, which maybe uses the word that you've just written to do the job. So what you do is you factor your application. You try and break it down into very small words which each have a very small part to play in a larger overall logical solution. The idea behind that is you test as you go and you keep on going. if this word here doesn't work when I type it in, I can just say, oh, okay, forget that then. That word's gone. I just type it in again. I don't even have to do that. I can just say, right, here's, you know, a very quick example. Here's the word test, you know, which puts 100 on the stack, and I say, oh, I wanted it to be 200. Well, okay, just redefine it. The other one is actually still in memory, but it's kind of
So you must be able to save the whole state. You know, when you're going to turn your machine off, whatever, you're basically just the way you had it, and then you boot it up again, and you're right where you were, right? Everything you entered and all your variables and everything.
yeah, and you do that by putting stuff in blocks.
Oh, right.
So everything in a block is executed as if you typed it at the keyboard. In fact, the compiler doesn't know the difference. When you load stuff in, when you use the word load, you give it a block number and you say load. The route through the compiler is exactly the same as from the keyboard. The compiler doesn't know that this is coming from a block. It has no idea. That means that there's no restriction on what you can put in a block. In fact, there is no executable code per se in here. This is all script, and is executed as it's encountered. It's actually the menu that you see at startup. So TurboForth is configured to load block 1 when it starts and just run whatever it sees in there. So if I just let it, so it opened up block 1 and just ran everything in there as if you just typed it in really fast. I can demonstrate that by, let's put something in there, you know. My favorite program, like that. I'll flush that because I changed it, and reset, and there's that. So it's important to realize that that there, as you'll see, there's no difference to how I would type that on the command line here. There's no difference at all. So it saw that, it compiled it into memory as object code, then it ran it from a script. And what you can do in this, you can, if say you're writing a game that's got things like a lot of graphics, for example. If you've ever done anything in extended basic or something like that, you'll know that you have some code maybe at the beginning of your program which sets up all your user-defined characters, sets the colors of your character sets, defines your sprites, and that kind of thing. And if you think about it, it's kind of wasteful because you've got your characters which exist in CPU memory as part of your source code. And what happens is when you run the code, it defines the characters in VDP memory, so that the data exists in two places at the same time, which is a bit of a waste. In this, you can write some code, define your graphics, all of them, and then you can tell it to erase that code, start compiling from the top of memory again, over the top of the graphics code, because they exist already, you've just compiled them into VDP